Hello, my name is Richard Lau. In this series of lectures, I'm going to talk to you about the many facets of the petroleum industry. We have designed this series for new engineering students. It may also be beneficial to other professionals who want to increase or update their knowledge. In these lectures, we will start with how the earth was formed, how petroleum was made and accumulated. We'll look at the process of how we decide where to drill for oil, how we actually drill for oil, how we complete oil wells, and how we bring oil to the surface. Then we describe how oil and gas are separated and transported to the refineries. In the refinery section, we will discuss how crude oil is separated into its many products. We will also mention contracts and leasing agreements, health, safety, and environmental items, and marketing issues with respect to getting oil and oil products to customers. Before we look for oil, let's talk about the formation of the earth. Chapter 1, How the Earth Was Formed. In this chapter, we're going to talk about the origins of the earth and plate tectonics. To understand where oil and gas come from, we need to understand first how the universe was created and then how the earth was formed from this creation. In discussing the early stages of Earth's creation, we will describe the theory of plate tectonics. In this description, we will see how they move, what happens when they move, and the changes that these movements create. We need to understand plate tectonic theory because it helps us in our quest to locate oil and gas. We'll start at the beginning of the beginning. From physics, we know that the beginning of the universe happened about 13.5 billion years ago. According to them, the universe began with a Big Bang, known as the Big Bang Theory. This theory says that a gigantic explosion produced all the energy and fundamental particles that are in our known universe. That means that everything you see, hear, touch, taste, smell, and know as your physical world was created at that moment. Imagine all of this happening 13.5 billion years ago. Remember, in American English, 1 billion is 1 with 9 zeros. So what was created 13.5 billion years ago? I said all the energy and fundamental particles were created. These particles in physics are called quarks. Quarks make up protons, neutrons, and electrons, which form atoms. Atoms make molecules. Molecules make solids, liquids, and gases, things that make up the earth. The Big Bang created quarks, with some of them turning into hydrogen and helium atoms. Over millions of years, the gravitational attraction between the hydrogen atoms created clouds of gas. These clouds began to spin, contracting to form stars. These collapsing hydrogen atoms started nuclear reactions. These clouds began to spin, contracting to form stars. These stars matured. As they began to die, they exploded into supernovas, gigantic nuclear explosions that created the other 90 or so atoms that we know today. With these new atoms, new clouds again formed by gravitational attraction, creating new solar systems made up of suns and planets throughout the universe. This is how our solar system was first created 4.55 billion years ago. This is how it looks today. This was billions and billions of years ago. It is beyond my understanding. As a human, I really can't understand how long a billion years is. When we speak of millions and billions of years, we refer to time from the point of view of a geologist or a physicist who must use these large numbers to measure the ages of the formation of the earth, the solar system, or the universe. Of course, in this class, we are interested in the third planet of this solar system. That place we call our planet, planet Earth. Now let's go back to 4.55 million years ago. The Earth is a pile of hot stuff. Everywhere there is molten atoms and molecules swirling and starting to coalesce into a round ball of solid matter. There is nothing here that you would recognize as the Earth as you know it. In these early stages, geologists have divided this time into two differentiations: early differentiation and late differentiation. The first 100 million years is called the early differentiation. During this time, two things happened. First, our molten atoms and molecules began to separate, which caused the higher density atoms like iron and nickel to sink toward the center to form the core. Second, the lighter, less dense atoms and molecules formed minerals and other rocks at the surface, which we call the Earth's mantle. In other words, it is during this early differentiation that heavier atoms sink to the core and lighter atoms stay near the surface. In the late differentiation period, we begin to have the formation of gases. The Earth is still very hot, and some of these light atoms that migrated near the surface to form the mantle begin to melt, which creates the crust and releases gases like oxygen, nitrogen, and water vapor. It is during this late differentiation that we begin to see the formation of our crust, our oceans, and our atmosphere. That we begin to see an Earth with familiar form and structure. Formed during late differentiation, the Earth's structure is as follows. The solid inner core is iron-nickel metal. Zone 2 is the liquid outer core made out of liquid iron-nickel metal. Due to the rotation of the Earth, this core swirls and is magnetic. This is where our magnetic fields, which give rise to our north and south poles, come from. Zone 3 is the rocky mantle, made of magnesium and iron silicate minerals. Deep down, it is hot and under high pressure. The rocks here are not really melted. They are soft like a hot plastic and can move. Sometimes they are further divided into hard mantle and soft mantle. Zone 4 is the rocky crust, mainly silicate minerals and cations, which are made up of metals. It is in this zone that we find our valuable, mineable minerals. Our continents are formed from the crust.